Hi guys, Buildzoid here, and I got one chance to do this, so if this video turns out to completely suck, well, I can't do another retake. I have one of these, not a million. So then, if you watch a lot of my PCB breakdowns, well, more like if you pay a lot of attention to PCBs, not just watch my videos, because ultimately I've not looked at this PCB that often, have I? But it should be fairly obvious to people that this is a RTX 2080 Ti. So, yeah. And today what we're going to be doing is we're going to just remove the power limit. Completely remove the power limit. There's going to be we're going to go full unlimited power. Like, I know a bunch of people, you know, they have their little software things, but the software is just telling you that the power limit is higher. What I'm going to do is going to make the card literally incapable of figuring out how much power it's pulling, so it can't actually decide that it's pulling too much power no matter how much power it actually pulls. So, and I just said power a lot of times in a row and now it sounds weird. Anyway, let's take it apart. Obviously, I have it on the Morpheus 2 heatsink here for testing purposes. If you're wondering where this card came from, there's a very brave fan of the channel who basically was like, "Hey, Buildzoid, I'm gonna get you to mod my RTX 2080 Ti," and I was like, well, because in the past he also wanted me to mod a Titan for him, so I'm like, well, evidently this person is hell-bent on getting a card modded by me, so let's try it, right? And at least I can turn it into some content in the process as well. So first let's disassemble this. Now, I have replaced all of the mounting hardware for the Morpheus. It's non-standard what I use, because I think the stock mounting hardware absolutely sucks. Yeah, see, that's what I was worried about, that it wouldn't make proper contact, and it doesn't seem to be making proper contact. Yeah, okay, so for the future, that doesn't work. For future reference, that does not work. So, as you can clearly see, I'm lucky I used a lot of thermal paste, but you can see how the paste goes over the edge here. And that's because the mounting holes that actually match up with the ones, like these inner ones, the inner holes on the PCB, these ones, they align with these, but these are like off-center, so yeah. I would not put a Morpheus 2 on an RTX 2080 Ti because I don't think they do. I don't think they have a different mounting hardware for any of them. So that rather sucks. That sucks a lot, actually. Okay, so that does mean I need to build this in such a way that it'll be compatible with the Founders Edition heatsink, which just means that basically I'm a bit more space limited in terms of the modification. But anyway, that's a good thing to discover this early, because I had no idea that was actually going on. Like, that's pretty bad, right? Like, that is completely missing part of the die, isn't it? Let's see. It's got to be missing it completely. Wait, which side is it? Yeah, that's no good though. Yeah, that is actually, yeah, okay. Yeah, that's definitely not, that's missing by a lot, because the corners here aren't even covered. So yeah, I wouldn't consider this advisable, because you're not going to be cooling part of the die. So that really sucks, because yeah, we need to run it on the Founders Edition cooler, which kind of, like, once I lift the power limit on this thing, this is going to get so hot. That's going to be insane. So anyway, first things first, since we're doing the power limit mod, we need to figure out which shunts go to what power sources. Power sources on the card, we got the PCIe slot, 2 8-pins. So here's our multimeter. We have it set to resistance mode, not continuity, because while the beeps are nice, they don't actually tell, like, there's a lot of things that'll measure relatively low resistance. I mean, just measure across a working GPU core, for example. That's completely valid. That's not a short circuit, that's the resistance of a turned off piece of silicon. So yeah, first things, so let's figure out our, well, very large, you know, small process piece of silicon. If you go on some older architectures, especially like a lot of 28 nanometer cards, those actually have relatively high resistances. But anyway, let's figure out which of these shunts goes where. Actually, I'll just check the I can't remember which of the pins on these is what. Well, it's not that one. Okay, so that's probably not the... It would help if I actually remembered the 8-pin pinout, wouldn't it? Never kept... Okay, let's try this one then. Nope. It's got to be one of these pins. Okay, well, we checked both of those, so is this one it? Okay, it's this one. Because, yeah. Okay, so this one right here is that 8-pin over there. This one, then, I assume is PCIe slot. Yeah, it is. It's PCI. Oh, and I pushed the multimeter. Yeah, see, this is... So, anyway, if we check this one down here, which could have been kind of... Bam! 0.04... Yeah, so that's PCIe slot. This one is up here. If we stabby... There. 0. And if we go on the back of the card, that should give us the last remaining connector that hasn't registered as anything yet. There. So, yeah. So we need to remove one shunt on the rear, and we need to remove one shunt on the front of the card. So let's get to the removal, which I'm going to start off with a hairdryer for that. I don't have a heat gun, so that's my PCB preheating process here. Hit it with a hairdryer until it gets uncomfortable to the touch, because this goes up to like 60 C. There we go. Yeah, that's hot. Ow. That's hot enough to be painful, so that's hot enough to start working. I didn't actually swap out both of my soldering irons to like the really fat chisel tips, but we should be good. So then, this guy over here. Okay, so I'm going to put the card this way. We need flux. Go. At you. So, let's get started. Neither of these are in particularly great condition. Man, the tripod's actually being a bit of a problem in terms of workspace, but... that's good. Got the other one. Go. And let's just go from both sides at the same time, and the idea is basically we're gonna pull it off. And I think I should have used larger tip on one of my irons. I really should have. Oh, there we go. Okay, so that's one of the shunts come off. So basically what we've done now is we've disconnected the 8-pin from the actual card proper, but we've essentially exposed the mounting pads for the shunts. And the important reason why we want to do that is, as you can clearly see, the shunt is a 2-terminal component, but as you can clearly see, there's 4 solder points on the actual PCB itself. 2 of the smaller tabs right there are the actual sensing inputs of the NCP4 something blah blah blah. Basically the chip that monitors the current on this card, it monitors the little tabs. It doesn't monitor the large ones, those are the actual power transfer. So what we're going to do is we're going to short together, we're going to have one side just hooked up straight to 12 volts, and then we're going to bridge that with a bit of wire so that we still get power into the card. And what else is there? We're going to run a voltage divider between 12 volts and ground and use the voltage from that to feed into the low voltage input of the current monitoring circuitry. So that it's going to think that it's pulling, like, my goal is to, so these were 5 milliohm shunts, let's just tell the card that it's always pulling about, you know, an amp off of the 12 volts, which translates to about 12 watts. So we should be, like, basically the card's going to think it's pulling 12 watts 24/7, and that should be enough that we don't trigger any protections, but low enough that we actually get an unlimited power limit. Well, this is the fun part where your soldering iron doesn't have enough power for the power plane you're trying to solder on. Damned cheap equipment. Well, likely I wanted to. Yeah, it just doesn't have enough power. Anyway, let's figure out which side of the shunt is which. So one side is going to go to the actual power connector. One side is going to go to the PCI, like to the actual VRM. So let's see what this side goes to. I think this side might go to the... Yeah, I'm in luck. And then this side obviously goes to the... Yeah, that doesn't go anywhere right now because it's not connected to anything. Yeah, okay, so I'm in luck. I actually, like, the mess I created is on the side where I actually was going to make it anyway, so whatever. All is going according to plan. Well, there was much of a plan to start with. Anyway, man, soldering on camera sucks. Go, so that's our low sense pad, and yeah, this pad's much easier to work with. Because that one isn't hooked into a power plane going to a power connector, so... Whereas this one is. Well, whatever. Okay, so now what we need is that we need a bit of wire to bridge across there. Basically, we're going to bridge... let's see. I don't have an implement of pointing. I need a pointy thing. That's fine. Well, this is why I don't do soldering videos. Because it's just like, I don't usually need to worry about explaining what I'm doing to people. I just do it, and then worry about the details of explaining it later. But anyway, so, let's see. Focus, damn it. There we go. Yeah. So this little tab, this pad right here, we need to put lower voltage into that. So that's what we're going to feed our voltage divider into. These two, as you can clearly see, are now bridged, which is fine because that one's supposed to see high voltage anyway. So that one's just going to see straight 12 volts. And then we're going to go from there to here with just a straight, like just a regular piece of wire, essentially. So that's all we're going to do on this side. And since we do need to get this working with the Founders Edition cooler, I am very likely going to run a wire from this pad all the way to up to the 8-pin connectors between them, you know, in the gap there, and then around the back. And we're going to do the actual modification itself proper on the back of the card because there's more space to work in here than there is on the front, because on the front there's the freaking heatsink, right? And the heatsink gets in the way. So that's the plan right now. Let's implement it. First, we need to build our little L-shaped solder bridge, and with some wire. So that means I need to get some wire. Is there any wire on this desk? No, of course there isn't. Which is rather odd, because normally there's piles of it. We have some white wire. Nope. I need... Where did all the... I had a spool of single-core freaking wire. Where did it go? That's really odd. Like, that's actually like the largest wire spool I have, so I really do wonder where it could have disappeared off to. Oh, there it is. I'm blind. It's actually still on the desk. It was just not, you know, standing, so since it was at a different angle than I was expecting, I didn't see it. So then, get some of this. We're not actually using this for like power transfer, we're just using it to bridge well, it will power transfer, but we're going to reinforce it with a great pile of solder, so it doesn't actually need to, like, the gauge of this doesn't necessarily matter that much, is what I'm getting at. How much do screw it, we'll just pull way too much and then cut it down to size. Cutting. Now I need a knife, and I don't have a knife, which is funny. Where'd the box cutter go? Oh, we'll just use scissors then, because we need to get the insulation off. And we need to get off a lot of insulation, because I'm actually probably going to use up the whole thing. Go. Come here. Yeah, I like that. That looks good to me. Might not look to anybody who's actually good at this, but go. One side in. Oh, there they are. Pro tip of the day, if you're going to shoot a video about how you do something, probably might want to prepare all your tools ahead of time. Yeah, it's fine. Yeah. It's not particularly concerning. I'll just bend it out of the way. Actually, I wonder if this will even clear now. It'll be interesting to see. I hope it does, because I don't really want to redo that. I touched the flux. Anyway, let's go double iron again, because just one of them isn't going to properly do much of anything. Especially not this one with the tip that's on it right now. There, much cleaner. And lower. And just generally better in my opinion. Much nicer attachment. There. So, at this point we've done basically 50% of the power limit removal. So, there we go. So you can see how one of those pads is still unoccupied, right? And we're going to run a wire to that one from a voltage divider. And that's basically all you need to do to remove your power limit. You remove the shunt, you short basically everything that was already shorted, basically short everything that was there except for that one pad. And then you need to feed that one pad with a voltage that is a slight, basically you need to feed it a slight drop from 12 volts. So a slight reduction. Not a big one, right? Just a very, very mild reduction from 12 volts. So, how much wire? I don't know how much wire I'll need. Let's just pull way too much. And, yeah, see that? That slots nicely between the 8 pins. That way when we put the Founders Edition heatsink on it, it'll still fit. Let's just strip this. And attach it into place. We're going to go. And, yep. Happy with that. I just realized that my flux tube is all sticky. Ew. Oh boy. Well, that's a big tube as well, so it's going to be a while before I get a new one. Well, more like before I need a new one. Come on, stay on the damn pad. There we go, and our little wire, mod wire, is attached. Now we can try wire manage it a bit, which basically means we're just going to jam it down there. I said jam it down. Is that as low as it goes? Really? That's not as low as it goes. Where's my knife? Okay, I'm actually going to go get the knife. Oh, there's the box cutter. Found it. But that's the wrong knife. Okay, so evidently the... Should have cleaned up after the dry ice session better, but, well, whatever. Too late for that now. Oh, we can just use one of these. That'll work as well. There. Now it's flush with the PCB. That's what I was going for. So, and we can just run it along like that, and yeah, that's not really taller than any of the SMD components in the area, so yeah, it's lower than that capacitor, so that should be perfectly fine. That should clear everything. So now we can move on to the back of the card, and this is the part I hate because you have to, you know, keep in mind that you don't want to be like putting pressure on this part of the card because you'll bend it. So I normally have a foam-like thing that I put under them. There we go. The most cheap, the cheapest, ugliest support for a card ever. It's actually what I built most of the 1080 Ti on, but actually all my, like the 1080 Ti's I have, I work on that for those. I don't want thermal paste on it. I'm gonna have to clean this off. That's a lot of Cryonaut to be cleaning off. That's a massive waste of Cryonaut. That really sucks. And I'm running low on the one tube I have. Well, whatever. There. Now we're safe from bending the card and potentially breaking it. We do need to remove the shunt that's still on the back of the card, so we're going to take care of that guy now. The card's back to being cold, so... Hair dryer! Ouch. Ouch is a measurement of temperature. It's usually about 60. Or, well, anything really, well, actually it probably depends more on the material you touch than what temperature it actually is. Because if you have something that's actually really bad at thermal transfer, then you could probably, like, it could be really hot, and if you touched it, it wouldn't really feel that hot because the surface that you're touching would immediately get, like, hit body temperature, and at that point, you know, more heat wouldn't necessarily, like, heat would take a while to get back into there. Anyway, let's go for this one. Oh man, that one was way, way cleaner. Yeah, that was way cleaner. Might be because I have this thing cranked all the way up to the max. This tip right here, not the other one. So, there. Again, we have our 4 pads. I just screwed up by soldering them too long. As in, like, the solder was sticking, but, anyway, let's check. No, not that they're damaged physically, just that it looks ugly right now, but whatever. Now we're going to check our resistance to the 8-pin that it's hooked up to. Which is going to be there. And I think it's this side, right? Nope. Am I stupid? Okay, that's definitely not the input. Wait, what? Am I measuring the wrong thing? Did I just desolder the one on the PCIe slot? No, I didn't. Wait, oh, I'm measuring the wrong freaking 8-pin. I'm stupid, aren't I? Am I? Yeah, I am stupid. I'm really stupid. Oh boy. Yeah, I was measuring the wrong freaking 8-pin. It's like, why isn't it measuring to which freaking... Maybe because you're measuring on the wrong damn freaking connector. Anyway. There. Right. So this side is power. So we bridge these. And then we go to there. And then we... White wire is going to go to that one as well. Well, white wire is probably going to hang off of that one. Okay, well, let's start the procedure on the patient. Where's this from? Is this the wire I cut earlier? That can't be it. It's not silver. There it is. Right? The other side, this happened no problem in here. Yeah, okay, now it's done. Oh, whatever, we'll just bridge it with the wire anyway. Where's my wire? There's the wire. Box cutter. Time to slash up my thumb. Which I actually have legitimately done. Stripping wire like this. Up. So, yeah. Actually, I'll pull a bit extra out. How much distance do we need? Not much. There we go, that should be enough. Oh, that's plenty. Bash you on. Go. Go. Got one side caught, so now we can catch the other side. Go. I am really failing at this one right now. Blobby as hell, but it's a power line, so who cares? So, we've done the same thing on this side now as on the other side. the camera would choose to focus. There. So you can see how I've still left that one small tab uncovered. And that's what we're going to use to... So we're gonna feed our voltage divider into. And I think I'm just going to build the voltage divider directly on the 8 pins themselves. Just because that seems like a convenient place to put it. There's not really much space on one of these cards, as you can clearly see. There's just SMDs freaking everywhere, so... Yeah, in terms of the voltage divider itself, we're looking at a 30, well, we could use like a 47 ohm or a 33 ohm or a 56 ohm to 120,000. There's other values you can use. I like 120K to 33. And the equation for what we're doing here is basically, which I'm actually just going to make sure that we're in the calculator first. So the equation for what we're doing here is we're going to take 12, right? And we want to drop 12 volts by about 5 millivolts, and that's what we want. So we're then going to multiply that by 33 divided by 120,000, which actually it would be like 120,000 plus 33 if you want it to be super accurate, but you get the idea, right? Like that's such a small part of that term that it doesn't matter. So we can see that that gives us about 3.3 millivolts. If we used a 47, we get about 47. There's a 56, we get about 56 as well. Neat. So, yeah. But that's basically what we're going for. So we're going to go with a... I think I'll use a 47 just because I think I have a bunch of 47s that I've like not actually used for anything, whereas I've been using 33s for this mod for ages now. Like I think all of my 1080 Ti's and even like a 1070 and some other cards that I've had with Nvidia style power monitoring, all of them use 33 ohm resistors. So in order to not run out of those, I'm going to use something different this time, which really is just going to change the... It's not actually going to affect the results. It's just going to affect the idle... Well, it's just going to affect the power reading we see in the operating system, but we don't really care what we see there. Plus, if we put the idle power consumption a bit higher, it's less likely to bug out. Because the issue is like this thing, but like... The issue with these cards is if you just short completely, like if I connected that pad that I left unconnected right now, it'll think that the card is pulling far too little power, and it'll lock us into idle. And that would really, really suck if that happened. So we want to avoid that. Oh, I found 47. Oh, somebody used those, so I'm not going to use those again. 68s, nope, use those as well. Fortunately for you, recently I decided that in order to have less of a mess on my desk, I'm going to have more of a mess in my resistor storage, because what would happen is I'd have resistors just lying on my desk, and I wouldn't want to go clean them up because, oh, I'd need to actually, like, you know, clean them up properly. Screw it, we're using 39s. Good enough for me. All right, we just need about 3 millivolts, 3 to 5 millivolts of voltage drop. That's all we really care about. So we have our 120Ks, we have our 39s, we can go to town. So the 120K goes to ground, the 39 goes to 12 volts, and what's in between those two goes to the pad and the white wire over there. So actually, we're probably going to be running 2 white wires at this rate because, yeah, I'm just going to pull it right here. And let's grab our 120. And we're going to figure out which one of these is ground, because I don't actually remember the pinouts for 8 pins at all, because you don't need to remember the pinout if you have a multimeter, because you can just stab things until you see 0. Like that. That's a ground. That right there is a ground. This right here is also a ground. How convenient. But this right here I don't think is a ground. Oh no, that's also a ground. Some of these are supposed to be sense pins. That's a sense pin. Right, 0.3. So anyway, so that's the plan. So we're going to get our 120K, which I just pulled off and dropped promptly because, you know, I'm great like that. Just got flux all over my hands again. Gonna go, I want to plan this out somewhat so that it's not just kind of willy-nilly all over the place. Also have that 33, well 39 that has to go in there. They're gonna be like... I'm trying to keep this neat, because a lot of the time I just kind of hang it wherever and it's just, well, my cards, I don't care. As long as the LN2 pot fits, I'm fine with it, right? But... I mean, another option would be we could pull the... We could put this resistor over here, and then just use a wire to pull it to this. That would also work. We put it down there. I don't really want to put it down now. Because ultimately, it doesn't matter where I actually source the 12 volts from as long as I get them somewhere. But, there's not much space on this PCB. Really be that? Let's see. We're doing it there. I've just made up my mind. I'm putting it right across the where the shunt was. So we're going to build it there, and then we're going to extend it out. Actually, we could pull ground to like a screw hole right here or something as well. That would be another option. I think I'll actually do it that way. That just seems easier. And then messing around with the connectors. Also, yeah, like... Then you have this wire run... whatever, it'll be fine. Well, actually trying to heat it up that much this time around. Actually, I don't think I heated it up at all, but whatever. Let's see. Great, okay, so I did not think that through very much. This has to be a bit tall in order to clear. This is a bit long still. This is what happens when I want to don't want to make a massive mess of wires. Oh, I'm pretty happy with that position. Let's get the... That's... Oh no, it's off. It's off. No, I need to move it, damn it. This is where I really wish I had a proper, you know, better soldering iron, but... Go. Well, it looks even more horrendous than before, but it should work. It's a lot of the time my primary criteria. Will it worky or not? And that should worky. And then we can just pull this wire to there. Actually, let me just check something on the Founders Edition heatsink and open a window. There's a hole in the PCB. Oh no, they have a thing going through that hole. Damn it. Okay, I was like, oh, there's a hole. We could run the wire through the hole. That would be so clean and nice and tidy and not a disgusting mess of wires running across the back of the card, but I guess whatever. Right? I mean, what did anybody expect from me? There we go. At least it'll definitely worky. Go. And you guys can't see anything again. See, I'm so used to like working in this corner of the desk because I don't have well, more like there would be more space if I ever actually cleaned up, but I'm cool with working over like my own lap with a soldering iron because there's not enough space on the desk. So, yeah, that kind of sucks for the camera. That's really ugly. This is way too hot. Put it back down to 400. Had it all the way up at 450, and well, the end result is that you get a whole bunch of disgusting mess everywhere. So, add some flux, and this. Okay, I need to clean this. If I don't, I'm gonna just like not want to touch anything on this desk within the next, I don't know, couple minutes. That would be really counterproductive, wouldn't it? If, you know, I couldn't do anything because everything on the desk was disgusting. So the only person that uses said desk. Oh, yeah, looks good to me. So next we need to get our 120K, which I've managed to lose again. Where'd the 120K go? Gee. Yay me. See, this is why I said the guy who like gave me this card to work on it, very, very brave man. Then again, I've never actually showed what my work process is like, so you might not have any idea. I'd say I'm still being relatively gentle with the card. I've not yet thrown it across the desk in frustration. Though that's usually reserved for motherboards. I've not yet had a card that had me that angry. Oh, whatever, we'll just use another one. As much as I hate wasting resistors, I'll probably find it again eventually, and who knows, I might have another Nvidia card that needs a power limit removal. You know, so it's not like it's going to be wasted if I find it eventually. So let's get our ground here. Set up. Yeah, this is a screw hole for the heatsink. Well, you're just not going to mount, like, not going to be able to mount that part. Whatever. Who cares? I don't. Should have done it on the outer edge, shouldn't I? Would have been neater. No, I wish I had the temperature higher again. So we're soldering a big fat ground plane, and the iron obviously can't keep up. Gonna be trimming this down. Okay, so we need to trim both ends down a bit. Still too long. See, the thing is, I don't like over-trimming things, because obviously once you've cut a bunch of material off, you can't add it back on, so... I want to cut a bit long and then keep adjusting it downwards. It's not like I'm going to whip out a ruler and measure the damn thing. Yeah, okay, I'm happy with that. How far do we need it? Oh, far. Okay. Nope. My thing. Okay. Come here. There we go. I mean, I could have trimmed it after the fact, but well, whatever. I'm probably still going to do that anyway. Because I still think it's a bit too long. Yeah, it's still a bit too long, but whatever. This may be a 2080 Ti, but that's never going to make my work any cleaner. Hell, I did equally well. I mean, this isn't even sketchy. This is actually relatively nice by my standards. It's sketchy when I start modding the feedback circuit in hopes of and not wondering if it'll even work afterwards, or modifying load line calibration and being like, or yeah, or modifying load line and being like, yeah, this is a great idea, on like no level at all, but. At this point, we should be done. Honestly. Yeah, I'd say that's done. So, yeah, I mean, the card's right now completely disgusting because there's flux everywhere. We're still going to run it on the Morpheus because evidently the Morpheus was good enough to not actually set the card, like break the card yet, but I wouldn't run it long term because, again, it doesn't cover the die properly. As far as I'm concerned, that's, I mean, I guess you could have like I guess if you had like machining tools, you could, you know, machine the base of the Morpheus lower. So, because essentially like the problem, which I don't get why they did that. Okay, like if you look at the base of the Morpheus, the problem here, right? The problem here is that the centerpiece is actually raised. Like the copper part is higher than the black part. So if you want this to work on a 2080 Ti properly with full die coverage, you'd need to like grind off the center copper piece and just sand it down until it's all one big copper square. And then it would work fine. I don't know why they have that raised section. I really have no idea. But anyway, for now this is going to work, so we're just going to smack some more Krana on there and roll with it. Now I'm just going to boot the card up and show you that it does indeed run. Maybe show you what it actually now reads in terms of power consumption as well. Or I might end up looking like a complete idiot because, you know, I tripped the power safety and we have to replace the lower value resistor, which is not going to be fun at all because that one's like freaking welded, well, you know, that one's in the biggest blob of solder straight to the biggest power plane, so, well, the larger power plane of the power planes available. Yeah. Anyway. Reassemble this, and see, this is why I have modified hardware with like the screws sticking out of the heatsink, because it makes it so much easier to install the heatsink, the GPU to the heatsink when you can just put the screws through the holes and bam, you're sorted. Then you just need to get your thumb screws, well, thumb nuts. Is this one? Oh, this one's coming undone. Okay, now I'm going to do something pretty sketchy. Oh, damn, I forgot the mounting hardware. Whatever. We just need to boot it up. Just to prove that it works. Maybe run like one round of Firestrike to show that there's no power limit anymore. Very gently. There we go. So, okay, so now it's time for a transition. So you guys are stuck staring at the lovely desk over here, and I'm going to go install the card and throw you onto monitor capture as soon as possible. Actually, you're not going to be able to watch the desk while I swap the inputs, so yeah, sucks to be you. So, go. Card is now installed. Up. Okay, so where's studio mode? Studio mode. We need blank, transition, and now I need to... Okay. So, at this point, assume all I need to do is unplug you, plug you in, like that. Now if I press power, it should show up. Actually, I'm gonna need to see what's going on, so give me a windowed projector. There we go. And transition again. Well, the card isn't spewing smoke, so that's a good sign, right? That's always a good sign. No smoke coming out of your hardware. Unless you're on like dry ice or liquid nitrogen, then no smoke coming out would be kind of odd. Card boots up as expected, so that's great. Great. Let's see what it does to the power limit. Okay, so let's just open up GPU-Z first and check out our power consumption. So right now we're using supposedly, yeah, so I set it a bit high, I guess. But that's fine, because ideally, if we press start render test, that's odd. Did Nvidia figure out how to get around me doing this? I'll hate them if they did. Let's just run Firestrike. But the mod is working because our idle power consumption is like freaking ridiculous. So evidently the resistor I used is a bit high, but that's fine. We can replace the one going to ground, since that one's easier to replace, so we could go up to like, I don't know, 100 like something bigger than 120K. It seems to be running a bit slow. It might have reset. I don't know. Like, I've not been messing with the card very long. I only... Well, I've not done much with it. Seems to be not working. Or, actually, no, it looks like it might be kinda... No. It's weird. That's very weird. That is super weird. I'm 100% certain that I wired up everything correctly. So why is it running? Like, it's running really slow, that's for sure. I just want to see if maybe, like, this doesn't change something, but that is so weird. I mean, I guess there's a bunch of other current monitoring circuitry on the rest of the card as well, but I would have expected this to be like the stuff the card relies on the most. Gonna be shunts for days on this thing. Yeah, it's still running slow. That is very, very odd. I am very confused. Now it's complaining about power. Yeah, and it's running like garbage. It's running like complete and utter garbage. That's so weird. That is super weird. Okay, well, there's nothing for it. we gotta fix this. Like, I'm gonna make the damn thing freaking run like there's no power limit if it's the last thing I freaking do. I can't believe that didn't work, though. Because that, like, if you do that on a 1080 Ti, power limit gone. Completely gone. Right? That's what all of my 1080 Ti's have. It's just literally this. But apparently, like, I don't know, maybe I set it too high, the modification. Like, it's feeding the card a value that's too, like, I should have used a basically different resistor ratio is what I'm getting at. There. So what we're going to do is we're going to replace that 120K with, like, let's see, let's try cut down the modification to less than half of what it is right now. So we should be going for like a 200 something. 220, I think. 220K. That's 470. That's way too high. 270. Let's go for 270. And since I'm prototype, like, I'm going to kind of prototype it right now, so... oh, forgot to transition. So... transition. So I'm gonna just like like, I'm just going to do this really kind of messy right now, but I'm going to pull this one up, like so. Come on, let go. No, you want to. There. Then we have our 270. Just gonna throw it on there like, no, like we just really don't care, because right now I don't. Ouch. Ow, burnt myself. Well, that's to be expected. There. That's sketchy. That's ugly. Not sketchy. That's really ugly, but it'll work. Basically, I just put the new resistor in there, just whatever like. So, yeah. Let's try this now. So this, in theory, should drop the voltage. The voltage drop, like the divider that we're setting up, like this should be much. Well, now we should be seeing like, because right, we're going down to 270, so 270 on this side. We still have 39 on that side, so we should be seeing like 1.7 millivolts. So it should be reading way lower now, like less than half of what we had before. So yeah, if it now doesn't work, then there's something like Nvidia has upgraded their current monitoring circuitry to a whole new level that's just incredibly obnoxious as far as I'm concerned, and we don't even need to transition anymore because we can just do that. And oh wait, forgot to plug in the GPU. Someone's a genius. Oh, the system card's not working. I wonder why. Is because the 8 pins aren't plugged in, idiot. Where the... I hate split 8 pins. Like, they're nice and convenient when you're on a 6-pin card, but when you're on an 8-pin card, they're just obnoxious. Apply fans. Okay. I was getting worried this was taking too long to post. So, now if we go into GPU-Z, it's still reading, it's reading less than before, but still not cranking up all the way. Well, I never actually checked that this worked before, so. Okay, we're gonna have GPU-Z running and just get 3D markup. First strike extreme, run. But still, like, I would have expected this to do, like, on a 1080 Ti, if you do this, the TDP basically stops changing completely, and here the TDP still changes, so I'm very concerned at this point that like there's a whole bunch of extra power monitoring circuitry, which would make sense because there's two NCP 45491s, I think, or is it 49451s? I don't remember. But the current monitors they have are 4 channels, and there's 2 of them. So theoretically, there could be up to 8 different current monitoring circuits on the card. And I just modified 2 of them, right? So if I got the 2 wrong ones, or the 2 I got aren't important enough, then the power limit hasn't changed at all, because, well, there's way more to do, which is really annoying, and I don't want to deal with the rest. Okay, now it seems to be running properly again, but I still don't think the modification has done what it's supposed to do. Yeah, now it's running more or less properly again. But that is so odd. Like, we're at what? Like, wait, did I do the math wrong, maybe? That's possible. Like, I make a lot of math mistakes, so... Like, basic math mistakes are, like, my number one enemy with anything is just like, oh yeah, I totally need to do it this way. Then I do it, and I'm like, oh, I'm off by an order of magnitude, or I'm twice the value I wanted, or half the value I wanted, so... Essentially, a lot of the time when I'm doing modding, I calculate everything like 3 or 4 times just to make sure that I didn't screw it up. Okay, no, now it's doing what it's supposed to do. So that is so odd. But yeah, you can see how now it's just like no power limit. But that is weird. That is so weird. That is super... Like, I thought this would blow the freaking power limit to Antarctica. But it's not doing that. Like, yes, the power limit is definitely increased, but I wanted the power limit gone, not increased. That is weird. I need to get one of these that, like, I have full reign to destroy, potentially, so that I can, like, stabby every inch of the card. And then just do stupid things to every circuit on it until the power limit's actually gone. There's got to be more power monitoring circuitry. Like, it makes sense, right? Why would you use a like, I'm gonna actually look into my freaking notes now, because, like the mod isn't working the way I want it to, which is fine, the card still works, right? But, I mean, I've wasted my time, and your time, and everybody's time, but that's super interesting. Anyway, so I'm just going to look into my notes about what the Founders Edition PCB actually has on it. And how many of them... There's definitely 2 of them. I know that. There's a lot of them. So, here's my 2080 Ti. Founders Edition. Notes. NCP 45491. Okay, yeah, so I was wrong. It's not 49451, it's 45491. Swap the 5 and the 9 around. Okay, yeah, 26 volt, 4-channel voltage bus, and 4-channel high-side current shunt monitor. So these have 4, yeah, so why would you use a 4-channel freaking shunt monitor? Like, yeah, why would you use a 4-channel monitoring chip if you're only gonna have, you know, 3 shunts? Right? Because because basically we're working with the assumption right now that there's PCIe power pin, PCIe slot, and then the 2 8-pins. You don't need 2 NCP 45491s to monitor that many inputs. So there's way more power monitoring circuitry on the card. Which we do actually need to modify. So if we wanted to completely eliminate the power limit, you would actually have to go and modify that as well. Which is annoying to say the least. That's very annoying. Though I think the cool thing is with this trick over here, you could theoretically rig up a potentiometer into it. Right? Like, you could use, like, yeah, like, because right now, what do I have? I have a 39 ohm to 270 kilo ohm, right? That's the divider that's going in there right now. If you wanted to, you could rig this up, put a potentiometer on either side of that divider, right? Or just use a potentiometer to be the divider, but you'd need a pretty... Like, the thing is, it's such a lopsided, you know, divider where you have, like, you know, 10 ohms to 100,000 ohms. So, like, a potentiometer is not really that great in that kind of scenario, but you could put a potentiometer in place of the, in place of, like, the 10 ohm resistor, or the 200 and, or, well, the 39 ohm in my case, but you get the idea. You could replace one of them with a potentiometer and then just turn the potentiometer down or up, depending on which side it's on, until you have no power, like, to even further skew the power limit. But this is interesting. So now we have no power limit. So I wanna see. I want to do a serious overclock. I'm gonna go into precision. I mean, we don't have no power limit, but we have a significantly raised power limit. So I want to see if it, like, stabilizes our clock speeds, because... Yeah, okay, so you can no, it's not really doing what I wanted. I was really hoping it would stabilize the clock speed, but nope. Even the voltage is changing a little bit. Yeah, I was really hoping that it would just lock the clock speed up, but it doesn't do that, so that kind of sucks. Anyway, let's see if it crashes now. So previously these settings would run. No, not that benchmark. Different, nah, I want Firestrike. It's not that I have anything against TimeSpy, I just run Firestrike way more often. Also, this video is really, really long, but as I said at the very start, it's a one take, right? Like, I have one chance. As much as I wish I had, like, Linus Tech Tips budget and was able to just, like, go through 2080 Ti's like they were candy, I can't. So we're stuck with one card and one take. Because I'm not taking all those mods, like, I can't restore the card to, like, stock condition to redo everything. No, I do still need to clean up that resistor that's on there. So previously, when running Firestrike, it would, like, with, like, the 145 offset, it would peak at, like, 2,130 megahertz, and it would bottom out at, like, 2085. But I guess we can also see if the score doesn't go up, right? Like, that would be a good indicator that the power limit mod actually did something. I think the FPS is a bit higher than it used to be. Then again, there's, like, run-to-run variants. Man, I'm annoyed. I'm really annoyed. I was hoping this mod would freaking kill the power limit. Like, if you keep the theory of this mod and keep eliminating power monitoring circuits on the card until there's, like, zero left, then yeah, it'll still work, but man, that's a lot more work than, you know, I was hoping for it to be. I wonder what the Firestrike single card Hall of Fame looks like. It looks really lame. Are you kidding me? This is, like, I think the score this is going to spit out might actually hit the Hall of Fame. That is so lame. So if you're wondering why the physics is running so good, we're on a 7940X at 4.8 gigahertz. I couldn't be bothered to get it to go faster. Yeah, so this should spit out around, I don't know, 18,300 or something like that, which is on the Hall of Fame, which is, as far as I'm concerned, super lame. You shouldn't be, like, running a 2080 Ti on air should not get you into the freaking Hall of Fame. Like, I'm just sorry, but... but no. Actually, no. It scores exactly the same. So let's check out our power readings. Oh, it's still tripping power limit, apparently. How is it doing that? How is it still... How is it... Wait, no. Min-max. There. Max power consumption was 77%. And yet, this stupid thing right here... Is that the end of the benchmark, perhaps? I guess it's power because... And then it's just VRAL, 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 idle. Okay, so yeah. Okay, in the past it would actually sometimes hit power in the, like, regular... Well, no, it hits it right. Okay, so the mod seems to kind of work. It doesn't work quite as well as I wanted it to. That's kind of annoying. That's really kind of annoying. Like, the theory's good, right? Like, on paper, this should work if you just went far enough, which we evidently haven't. So, this is great. I'm a bit disappointed. Actually, I'm quite disappointed. Anyway, we need to clean up that resistor that's hanging out on the back. I'm not sure if it makes sense to even leave the mod on there at this point. Like, I could technically clean up the card and like put it on like 3 milliohm resistors, though I'm not sure if those would actually not trip the limit. They might. Those might trip the limit. So, yeah, that's freaking stupid, isn't it? But at the very least, we've discovered something. So, everybody be very thankful to the guy who was brave enough to send me this card, because that takes some serious guts. Yeah, I'm disappointed. The freaking power limit, like, it should be removable, because it's not like Nvidia's using any kind of freaking, I don't know, like, magic, like, it's not like there's some magic system that just measures the power, right? Like, there's circuitry that measures the power using shunt resistors. There's just more shunt resistors than what I dealt with. So we need to clean this horrible monstrosity up, and after that we're done with the video. So you don't need the multimeter anymore. Just need to trim that down a bit, and first we need to actually get it off the card. Speaking of, the card is very cold, so where's the hairdryer? Now, if you're wondering if this is the last video with the only video with this RTX 2080 Ti, don't worry, it's not. The very brave person who sent this in didn't actually even want a power mod. What they wanted was a memory cap mod. So the card's going to be getting a whole bunch of extra capacitors for the memory, and hopefully that'll make the memory clock higher. It's also going to get a modification to bump the memory voltage up a bit. And by a bit, I really do mean just a bit. We're going to go from like stock, which is 1.35 volts, to 1.39 volts. And the reason why we're going to 1.39 volts and not any higher is because the Micron GDDR6 memory specifications basically consider, what is it? Like the GDDR6 specifications from Micron, which are like standard JEDEC, basically say that the maximum normal operating voltage is supposed to be like 1.39 volts. So there's like a range of like 0.1, like I think it's like 1.31 to 1.39, and ideally you want to be at 1.35 volts, but you can be within that range. So we're going to go to the top of that range, and we're going to sit there. That's the plan, and hopefully that'll make the memory clock a bit faster. Yeah, we'll see how that works out. And then this power mod obviously is like, I'm disappointed, but mostly like I'm pretty sure given enough time I could take the power limit off. I mean, that looks like a shunt to me. There's a whole bunch of other components on the other side that also look like, well, that is a shunt. It's just like I'm not sure if that's a current monitoring shunt. But there's a whole bunch of other like shunt resistor components all over the card. It's just like, yeah, so basically it would be a matter of running the card, monitoring what they're doing, because it makes sense that they have a whole bunch of other current monitoring circuitry, because if you, like, Nvidia says that they have like a whole bunch of current balancing stuff going on, right? How can you balance the current if you're not measuring it? Exactly. So they do actually need to measure the current somewhere downstream in order to be able to balance the 8 pins, right? So it makes sense that the modification didn't work out quite as smoothly as I was hoping for, but I was really hoping that the current balancing circuitry wasn't actually being used in like the TDP calculation. Like I was just hoping that was doing its own thing for current balancing, and the TDP was just, you know, the main shunts. Why would you be redundant on that part? I don't. Well, it makes sense. I guess when an idiot like Buildzoid turns up to modify your card, it makes sense to make your current monitoring circuitry redundant, especially since it's already there, isn't it? So, but still, it's just like, I have been defeated for now. It no look pretty. I mean, it never looks pretty when I do anything, but this looks less pretty than what I'm used to, so we need to clean that up a bit. That looks horrendous. It needs flux. Up. And, well, that looks a lot cleaner, but now the wire came undone, so that's not going to work. Man, trying to solder 3 different things to the same spot sucks. That looks horrendous, but... Well, now I've burnt off all the flux again, so... I maybe didn't run the freaking thing so hot, so... Yeah, no, that just looks terrible. First, let's get that cleaned up. Okay, that's nice and clean now. Clean up the wire. Well, the wire's coming apart, but that's fine. Now, what we touch is a wire. There. It's not perfect. It's actually pretty far from what I would consider perfect, but it's not going to come apart, and it's not completely terrible. Yeah. Okay. So there. That's that's what I'm going to settle for here. I mean, it works, and it's not going to come off, but it just looks really, really ugly. But hey. So yeah, that's the power limit. I'm also gonna clean up the screw hole a bit because I'm like that's just horrendous. Again with the heat. Clean up the screw hole. And there. That looks relatively not terrible, so... Yeah, we'll roll with that for now. I'm super annoyed, though. Like, I was so ready to just, like, celebrate how the power limit is just completely gone. And it kinda is. I mean, the card thinks it's pulling 70% power consumption when it's probably doing more like... Well, more than that. Way more than that. But still, I was hoping for the card to think it's pulling 20. Right, that was my goal. My goal was to get the card to think it's pulling like 20% of TDP or 10% of TDP. It thinks it's pulling 70, which is still a win, right? Because before, when I was testing the card, it was actually hitting like, I don't know, it was hitting like over 100% TDP power consumption, but, well, TDP usage, but, you know, it's like, it's not perfect. It's really far from perfect. Like, it's nowhere near the effect that I get on 1080 Ti's or GTX 590s, right? So, yeah. I mean, at this point, I'm just going to disassemble this again. And I'll figure out what to do after the end of this video. So I guess it's the end of this video. So, I mean, thanks for watching. Like, share, subscribe. Like, share, subscribe if you feel like it. Leave any comments, questions, suggestions down in the comments section below. And again, one last time, you know, huge thanks to the guy who was like, yeah, Buildzoid, you can totally mod my 2080 Ti. That's a great idea. Never been a worse. It's a great idea. So yeah, I'm super thankful for the opportunity. Because I mean, like I've learned something new, right? Like I get excited when I do something and it doesn't work, because that means I need to learn something to make it work again. But yeah, I'm going to stop here with the power limit, because ultimately I agreed to do like cap mods and volt mods and that kind of thing. The power limit was just kind of something where I was like, I'll totally make some great content out of that. Well, you can be the judge of that. Anyway, so yeah, one last thank you to the guy. And if you'd like to support actually hardcore overclocking, I have a Patreon. There's also t-shirts you can buy. There's also socks you can buy. There's a link to Teespring for all of those things down in the description below, as well as, of course, the Patreon, and all of those help out immensely. And yeah, I have work to do on this 2080 Ti, and you're very likely going to be seeing it in more videos soon. Probably. So yeah, that's it for the video. Thanks for watching, and I need to go and hit the stop button, which is obviously not at the soldering area because the computer's like as far away from that area as it gets. Goodbye.